Hey students, I wanted to thank you all for your honest feedback on the survey that you took today. I've got 3 more sections that still need to do it, but one of the things that I was told was it would be really helpful if I did a little bit more lecturing to sort of explain concepts, and I think that's a great idea. So what I thought I would do is actually summarize what we did in the lab. That was kind of where people said they wanted some help. So we played with the motion detectors either this week or last week. And so I just kind of wanted to summarize some of the results that we actually got. So when we get a graph that looks like this, that graph means that we start off slow because it's flat. And then as it gets steeper, we realize that's faster. So when we look at both of these ideas here and here, we realize this is a graph of an object that is moving forward and speeding up. Its corresponding velocity graph, you start off slow and go faster and faster. Now it turns out the new idea that I wanted to kind of put into this video is for the acceleration. It turns out the slope of the velocity graph is your acceleration. What I want to do now is kind of run through the other 3 graphs really quickly just so you have an idea of how they work. So let's look at moving forward and slowing down. Well, if I'm moving forward quickly, I need a steep slope, and then I need my slope to level off to flat so that I come to a stop. So moving forward, slowing down looks like this. My velocity graph needs to start off as going fast and then slowing to rest like this. And finally, my acceleration graph, once again, is going to be the slope of my velocity graph. It's a negative slope, so it's going to be down here. All right, let's take a look at what happens when we move backwards and see what those graphs look like. For moving backwards, I'm going to start, and let's do moving backwards and speeding up. So I need to start in a positive place, and then I need to speed up, which means my slope needs to get steeper, and I'm moving down the vertical axis on my graph because that means I'm moving backwards in real life, and I need to get steeper to go faster. So I'm going to get an acceleration, I'm going to get a position graph that looks like this. So this is backwards, speeding up. The corresponding velocity graph, it's actually going to start at 0, and then I move backwards faster and faster. Finally, my acceleration graph is the slope of my velocity graph, negative slope, negative acceleration. Lastly, let's take a look at the graph of an object that's moving backwards and slowing down. So I need to start off steep and then flatten out going backwards like this. So this is position versus time. For velocity versus time, interesting, I need to start off fast and backwards and get slower and slower to approach 0 to stop. Now the interesting thing here is my acceleration graph, don't go with your gut feeling, go with the math. This slope is positive, that means this acceleration graph is positive. And we're going to actually need to talk about why in future videos and lectures. So again, this is a summary of the graphing lab that we did with the mini carts and the motion detectors. And on this Haiku page, you're actually going to see a more legible, downloadable PDF that summarizes what we did in lab. So again, thanks for the feedback. I'm going to try to keep these lectures happening on a little regular basis. I'm going to try to keep them 5 minutes or under, so I hope this is helpful.